Hello, my name is Matt Balder, and I'm the remotely operated vehicle technician for the Classroom Robotics at Bud Bay program. I'm going to talk a little bit today about ROVs and how I got started working with them. I'm also going to talk a little bit about what my ROV setup is. I'm going to speak a little bit about how I use ROVs to support learning and science, and I'll finish with my goals for future uses of ROVs. So I got started working with ROVs out of an interest in drones or unmanned aerial systems that started back in about 2015. I'm also a scuba diver, so I really enjoy underwater exploration, and kind of putting those two interests together kind of led me to getting into ROVs. So I purchased my first ROV in the spring of 2018, and the model I chose is called the SOFAR Trident. I chose this because it's a complete product and it only required the addition of a tablet to run a special app that enabled me to control the ROV underwater. Some of the functions that are controlled through the app are maneuvering the ROV underwater, stopping and starting video recording, and turning the lights off and on. So I'll talk a little bit about my ROV setup. My ROV setup consists of many different components. The ROV, which has 3 thrusters, camera, lights, and a waterproof hull. A tether. I have a 100 meter and a 25 meter tether, and they connect the ROV to a Wi-Fi topside unit. The Wi-Fi topside unit receives control signals and transmits video from the ROV and the SOFAR cockpit app installed on the tablet. The tablet I use is an NVIDIA Shield K1, and it has the SOFAR cockpit app installed, and that's used for controlling the ROV and displaying a live feed first-person view video from the camera at the front of the ROV. I use a game controller that is connected wirelessly to the tablet to provide joysticks and buttons used to control the movement of the ROV in the water. I also use the game controller to start and stop video recording and turn the lights on and off. A first-person view goggle setup is used to duplicate the display on the tablet and make controlling the ROV more immersive, as well as blocking out sunlight, which can make controlling the ROV difficult due to glare on the tablet screen. I've also made some modifications to the Trident in order to carry a macro lens. A macro lens is a dedicated camera lens that is optically optimized to handle extremely close focusing distances and take sharp, highly detailed images of microscopic subjects. I chose the plus 15 Macromate mini lens because it's easy to use underwater without having to compensate for water between the lens and the actual ROV camera. In order to mount this lens, I had to come up with some 3D printed mounting brackets and buoyancy pods in order to counteract the extra weight of the lens. In addition to that, I needed to add an underwater LED light because macro photography, I found, needs more light to turn out correctly. I use ROVs to support learning and science in a few different ways. I participate in 2 marine science education programs currently in Olympia. The Stream Team's Marine Creature Mondays was my first opportunity to use the ROV to show the public a live video feed of what lives below our waters in Puget Sound. This was also an opportunity to share ROV technology to people who wanted to learn more about it. The next opportunity I had to use the ROV for learning and science was participating in the Puget Sound Estuarium's peer-to-peer events. This experience was very exciting because they happened at nighttime, so a different set of marine life and behaviors became visible to observe. Both of these programs have been great opportunities to show the public the valuable resource we have in Puget Sound, as well as to share how ROV technology works. Never before has exploring underwater with ROVs been more accessible than it is today. The quality of video resolution that is now available is better than ever, and the ROVs are easier to use. I have a variety of goals and ideas for future uses of ROVs in different endeavors. I currently have a small business that offers aerial drone and ROV services. Some of the ROV services that I offer are underwater video inspections, search and recovery, and aquaculture surveys. I would also like to continue my participation in marine science education programs such as the CRABB program. I would eventually like to upgrade to a bigger commercial ROV that has the capability of taking underwater samples, using robotic arms, and having the ability to carry more lights and capture different camera angles. Other interests I have and would like to explore are autonomous underwater vehicles, or AUVs, that have the ability to navigate on their own underwater and complete pre-programmed missions. AUVs make use of machine learning or artificial intelligence technology that lets them make decisions on their own while in a mission. I look forward to working with you all in this program, and feel free to reach out to me with questions or areas of interest that you'd like to talk about. I'll put my contact information below and feel free to reach out. Thanks a lot.